Hey, Assalamu alaikum all. How are you? This video is basically the continuation of the previous one. In that, we have seen what is empirical formula, what is molecular formula. We have seen the differences between them. So, molecular formula is actually the actual number of atoms in a compound, and empirical formula is the slightest or simple whole number ratio of atoms, or you can say the most reduced form of the atoms present in a compound. So that was all about differences between them. Today I'm going to show you how to derive the empirical formula if you are given the percentage compositions, and also we will find out how to find out the molecular formula using the empirical formula masses and all the stuff. So here we have different steps to derive the empirical formula. First of all, so in order to find the empirical formula, you need to know different steps. The rule number one, you have to determine the percentage composition, and you have to find the number of gram atoms, or you can say the number of moles of each element. For this purpose, you have to divide the mass of that element, which is given in percentage composition, with its own atomic mass. And third, you have to determine the atomic ratio, and to get that, divide the number of moles of each atom with the smallest number of the moles. You have to determine the atomic ratio. So kids, the next step is, if the atomic ratio is simple, it's the empirical formula. Otherwise, you have to multiply with at least with the least suitable integer. It can be 2, it can be 3, to get the whole number. So determination of percentage composition, finding the number of gram atoms or moles, and then atomic ratio, and then to simplify the atomic ratio if it is not a simple whole number. Okay, here you can see all the rules which I have written for you, so have a look. Okay, we have a problem of we have a numerical, and I'm going to show you how to derive the empirical formula using the percentage composition. So a compound ethylene glycol is an antifreeze. It contains 38.7% of carbon, 9.7% of hydrogen, and 51.55% of oxygen. What is the empirical formula, and what is the molecular formula if the molecular mass given is 62.07 grams? So my first step would be percentage composition, and 38.7% of carbon means 38.7 grams of carbon in 100 grams of compound. 9.75% of hydrogen means 9.75 grams of hydrogen in 100 grams of compound, and 51.55% of oxygen means 51.55 grams of oxygen in 100 grams of compound. So the next step would be the number of gram atoms, or the number of moles of each element, and to find the number of moles we have the formula like that. We have the formula mass of each element, which is given in the form of percentage composition divided by the atomic mass of that element. So let's see. For carbon, we have the percentage composition 38.7 grams of carbon divided by its atomic mass, that is 12.01. It will give you 3.22. You can see the gram. We can say the gram atoms, or the number of moles of carbon. And secondly, we have 9.75 grams of hydrogen, that is divided by its atomic mass, that is 1.008, and it will give you like 9.67 gram atoms, or the number of moles of hydrogen. Thirdly, we have the number of moles of oxygen. Thirdly, we have the moles of oxygen, that is 51.55 divided by its atomic mass, that is 16.0. We need to be very much accurate in that. In atomic masses, 3.22. They can be gram atoms, or the number of moles of oxygen. So we have found out the number of moles of each element. Now the next step would be the atomic ratio. So for atomic ratio, just write down in this ratio form. And now what you have to do, you have to divide the number of moles of each element with the smallest number of moles. So here you have to identify which one is the smallest number of moles. Of course 3.22, or you can say this is this least number of moles. So what you have to do, you, in order to find out the atomic ratio, you have to divide each number of moles with the smallest number of moles. Here you can see 9.67 divided by 3.22 and 3.22 divided by 3.22. It will give you the ratio like that, like 1:3:1. Now you can see these are the simple whole number. So I told you before, if your atomic ratio is in simple whole number, that will be your empirical formula. So you got a subscript for C, you got a subscript for H, and you got a subscript for O. For C you got 1, for H you got 3, and for O you got 1. So from this step we came to know that our atomic ratio was simple whole number, and we have already discussed this thing. If the atomic ratio is in simple whole number, that would be the empirical formula. So we got the empirical formula, and that is CH3 and O, because we don't need to write H, we don't need to write 1 as a subscript with the number of as a number of atoms with each element symbol. Now the next step is to determine the molecular formula. So we can find out the molecular formula from empirical formula, but like that molecular formula is equal to empirical formula into N. Now the question is, what is N? So N is the molecular mass given divided by the empirical formula mass. So we were given with the molecular mass 62.07 grams. Now we have to find out the empirical formula mass. So to find out the empirical formula mass, first of all, write down the empirical formula. That is, we have already derived, that is CH3O. And in order to find out the empirical formula mass, we have to add up all the atomic masses like that. 12.0 for one carbon, because we have only one carbon, and H3 we have 1.008 into 3, because we have 3 hydrogens, and we can say plus 16.0, because we have only one oxygen. It will give you like 31.03 grams. Okay, so now to find out the N, we got the value, that is 62.07 divided by 31.03. It actually gives you the N value, that is 2. So now you got the N value 2. So we can put it here again, that is molecular formula is equal to empirical formula, that is CH3O into N. In short, you have to multiply with the empirical formula with this subscript out here. So it will give you like, it will multiply with all of them. So it will give you like C2H6NO2. So this is the actual number of atoms of this compound, ethylene glycol. This is the molecular formula. This was empirical formula. So that's the thing, and you got your molecular formula. Thank you all.